Suppose A is an n by n invertible matrix. In terms of the determinant of A, calculate the determinant of the adjoint of A. Now, what we mean by in terms of, we might eventually find that the determinant of the adjoint is always one more than the determinant of A. Or maybe it's always twice the determinant of A. So we're asking for in terms, what we want is a formula. You tell me the determinant of A is 3, I do this, 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 and I calculate the determinant of the adjoint. That's the idea here. Okay? Neither of these is going to be true, but that's what we're looking for. Just some formula, some expression in terms of the determinant of A. So it's a challenge question. We're going to tie together a number of bits of theory that we've seen over the last little bit involving determinants and adjoints. And what do we know about the adjoint? Well, we're told A is invertible. So the determinant is sort of a stepping stone to finding A inverse. So that's interesting to note. We know the determinant of A inverse. We've got that relationship. We know the adjoint is made from cofactors. Something else which we mentioned in the lesson is if you take A and you multiply by its adjoint, you get a scalar multiple of the identity matrix. Now, they tell us A is size n, so the adjoint's going to be size n. So this identity matrix is size n. So we've got sort of a scalar multiplication here. Determinant of A is some number, like 3, and we're scalar multiplying the identity by that amount. So it's this relationship that I want to focus on. This isn't the only one that will get you the appropriate answer. But it's this relationship that I want to focus on for a moment. If we apply the determinant to both sides, we've got a matrix product over here on the left, and we've got a scalar multiplication. It's going to be hard to keep track of all these determinants, but we have a scalar multiplication over here on the right. So on the left, well, we know that the determinant of a product is the product of the determinants. And the reason I do this is because, well, look what we've got over here. The determinant of the adjoint, which is exactly what we're looking for. Now we also have the determinant of A over here. But what happens on the right-hand side? Well, we've got a scalar multiplication. Now, think back a few lessons. What does the determinant do to a scalar multiplication? The scalar can pop out front at a cost. What was that cost? Think for a moment. You raise it to the power of however many rows, whatever the size of your matrix is. Okay? This is why in the question, bother to mention that it's an n by n invertible matrix. So if it's 3 by 3, we'll raise the determinant to the power 3. If it's 10 by 10, it's determinant of A to the power 10. So it very much depends on the size. Okay, great. So we've got the determinant of A here, we've got the determinant of A here. Determinant of the identity matrix. Do you remember what that is? Well, it's just 1. The determinant of the identity is 1, because there's 1s along the main diagonal, and we know the nice trick for the determinant of diagonal matrices. So we've got 1 copy of determinant of A over here. We've got the determinant of the adjoint, which is what we're after, and then we've got n copies of determinant of A on the right. So if I just wanted to isolate for the determinant of the adjoint, I suppose we could try and divide by the determinant of A on both sides. And this is why they mention it's an invertible matrix, because you can't divide by something unless you know it's not 0. But in an invertible matrix, we know the determinant of A isn't 0. So let's divide both sides by it. So we'll get rid of it on the left, and we'll be left just with the determinant of the adjoint. And on the right, what's going to happen? Well, we've got n copies of the determinant of A multiplied together, and we're dividing by just one of them. So this simplifies to determinant of A to the n minus 1. And that is the determinant of the adjoint. So all you need to know is the determinant of A and the size of A in order to make sure you've got the right answer. Okay? So you tell me the size, if it's a 4x4 matrix that has a determinant of 2, then suddenly you're looking at 2 to the 4 minus 1, or 8 for the determinant of your adjoint. Okay? So that's the idea here. Nice little formula. Very interesting. The formula itself is kind of a good thing to know, but this is definitely sort of a proof territory in terms of what we actually showed and how we worked things out. And that's what made it more of a challenge question. But definitely this relationship here is an interesting and useful one.